to the week 4 topics, which involves the instruction sets like the data transfer instruction, arithmetic and logical instructions, bit manipulation, jump and loop, program control, and of course the conversion from C++ to assembly language. But before we proceed with that, okay, let's have an example of the assembly language program that involves a conventional format. So what do we mean by conventional format? So conventional format means you will be use the segment directives. So we have here a sample output of the program, which we are required to write a conventional segment directives. So with that, we'll start with the data segment. Programming. So we have there the data SG, which is for the segment para, and that is a data. Okay. Now, so as you can see here, we have different string. So we have here the prompt, first prompt, the second prompt, the third prompt. We also have a string variable, and of course, since we will be asked to count, so we will have a counter. Okay, so we will use memory location for the counter. So say we have here enter, we find byte, so we will have the enter your name. Okay, and then of course find what character. So we can say, for example, have name, so db, so we define a 50 with initial content of 0. So now we will be using also the duplicate directive, so that it will initialize 50 bytes just for this, because otherwise whatever you input, it will overwrite the next byte. So say for example, what's the next byte? Find, so we have there find db. So if you will not have this, okay, so say I enter rows, so rows, so say I don't have this, I will have rows, so R will be in this part, and then at this address you will save the O. Okay, so that's the difference. So I will just go back there. So we will be initializing, so we will add some kind of allot. So we will allot a memory location or 50 bytes for the for this particular string. So that is 50 dup, and we initialize that with $sign, so that, say for example, I entered only 9. The 10th byte will be a $sign. So we need not have to insert the null value or the end of the string. So fine. So as you can see here, before you print the F, what happens? So you already next line and carriage return. So with that, we can write 10, 13, and then find what character. Okay, and of course $sign. So we have here the character. So the character can be saved in the AL, okay, in the lower accumulator. And then we have the third prompt, so there, so define byte. So also you have the line feed carriage return before you print out T. So we will do the line feed carriage return before we print there R. Okay, and then of course we have here the counter. So we can have counter db initialized at with 0 initialization. So in this case, we have data SG, and then segment end S. Sorry. So we have here segment end. So we have to end the segment. Now, so we're done already with the data segment. So we can proceed with the code segment. Okay, so let me just save this one. Okay, so we can proceed to the next one. Data. Okay, so now, so I may continue. So in this case, we can now write the code segment. So for the code segment, code SG, so segment, okay, so para code. So this time we will be using the assume, so the data segment should be data SG, and the code segment register should have the code SG. Okay, so once we already have that, we can now initialize the we can now create the procedure. So with that, we have the main procedure. So move AX, whatever the address of this, so that is the data SG, and then save that to the data segment register. So now we can now proceed with the programming itself. So in this case, move AH9, okay, so load effective address TX, whatever the variable here, and that is the enter, okay, interrupt 21H. So what will be the next one? We have to enter a string. So how do we enter a string? So move AH10, so load effective address TX, whatever the address of the string, and that is the num, okay, interrupt 21H. So after we've already inputted the string, we can proceed with the outputting of the prompt, which is, so move AH9, so load effective address TX, and that is find interrupt 21H, and then we have to input a character, so move AH1 interrupt 21H. So whatever the inputted, it will be saved in AL. So for the meantime, we will not be moving the content of AL because we will not be asking to input another character. So we save the inputted character in AL. We keep it there. So what's the next thing we do? So the next thing we do is what do we want? We want to check if this particular string contains int. So what are the factors do you have there? So of course, the memory location, right? Because this string is saved in the memory location. So therefore, we will be using an indirect addressing. Why indirect addressing? Because the address must be variable. So with that, we have the load effective address BX. What is the address of rows? So remember that is a string. So that is the third byte. So which means we have the num plus 2. So, okay, so since that is you will evaluate character against character, and since we have a collection of character, we will need a loop. So to implement the loop, we need to have a value for the count register, and to do that, we have to move in CL whatever the actual, whatever is the actual. So this part is this one, okay? And this part, this particular address is this, okay? So move CL, how do you get this particular address? We know we have already a given address, which is this one. So therefore, we can do num plus 1, correct? Okay, so we already have the looping, okay, the memory to be evaluated. What do we need next? Now we can, what we call this, compare. Now, so how do we compare? So we can now compare the content of bx with the al. If that is equal, jump if equal, then it will count. Otherwise, it will proceed to the next. Okay, it will proceed to the next element. Okay, so how do we proceed to the next element? So that means we have to increment bx and then perform the loop. So in this case, so where are we going to loop? So assuming that we loop in this particular part, okay? Now, then once all the element is evaluated, what will be the next thing to do? So it will out. So say for example, if that is equal, what will happen? So we have here a value of count. So we have here count. What it will do? It will increment the counter. So once it increments the counter, also it will increment the px, okay, and then jump to x. Okay, so increment bx to proceed to the next character and then jump to x. Okay, so what if that is not equal to e? So if that is not equal to e, it will proceed to the next character, which is o. So to go to o, increment bx, okay, and then loop. Okay, so in this case, now it will compare again the content of address in bx, which is o, against whatever the value in al, which is e. Okay, so if not equal, again it will increment to check the s. Okay, not equal, it will increment and it will check the e. So e against e, that is equal, so therefore this will be executed. Now anyways, so after you've already evaluated each element, what will happen? So that means, how will you know if each element is evaluated? When the cx is equal to 0. So after the cx is equal to 0, what will happen? We have to output this prompt. So that means we'll have move AH9, so load effective address bx, that is there, and then interrupt 21h. So after that, it will output the counter. So to output the counter, how do we do that? So we move the counter, so move BL counter, and then we make it a ASCII character. So add BL 30h. And now we can proceed with move, what's the next? Move AH2, move, interrupt 21h, because we have already the value in BL. So after that, what will happen? It will terminate the program. So I will just adjust this one. So the next one will be, it will terminate the program. So move AH for CH, interrupt 21H. Okay, and then we can now proceed with the count. What is the count? So increment counter, increment bx, and then jump to x. So in this case, we can now close the code segment. So code seg, code sg end, code sg end. Okay. And of course, lastly, end main. Okay. Now, can we still maximize this program? So as you can see here, we have your increment bx, and at the same time, we also have the increment bx here. Right? So we have the increment bx and then increment bx. What can we do so that we can max and optimize the program that we don't need this? Since it will jump here, why not before it can compare, it can increment the bx. So say for example, this one goes here. So that means instead of having your x here, so your x will be here, and then you have the increment bx. So this will not be here anymore, this will not be here anymore. But there's a problem with this. What do you think will be the problem? So if you will increment bx, that means that the address will no longer be num plus 2. It will be num plus 3. Okay, so in this case, num plus 2 is r, addresses to r. So when increment bx, it will now address the O. So what can we do so that we can optimize the program? Okay, so that means here, instead of having plus 2, we can do this as num plus 1. So in that case, if it increments, that will become num plus 2. Okay, so that will be the code for that. So these are the data. This is the data segment. So this is the procedure. So you have the outputting of character, outputting of string, input of the string. Okay, output of the string. So input of the character. So this is where you will save the CL for the loop. So this is the BX. Okay, so which means you are addressing, BX will contain this address, okay, initially. However, when you increment BX here, with this, it will now address this one. So now we compare the content of BX with AL. That is equal, it will count, okay, and then it will loop to X. So before it compares, it increment the BX. So this is output of the there. Okay, so once the counter becomes, or the counter register becomes 0, which means all the elements of the string are evaluated, it will output the string there. Okay, and then it will convert the counter, okay, the counter from BCD to ASCII character, and then it will output the character and then terminate the program. Okay, so of course, for the count, it will increment the counter and jump to back here to evaluate each of the what do you call this? Each of the